Dear students, the topic of my today's lecture is yarn guiding devices on ring frame. The devices we use for guiding the yarn from front roller nip to the winding on the bobbin. Mainly three devices we use. First one is lappet, then balloon control ring and separators. This one is a diagram of lappets fitted immediately over the spindle. The thread guide has to guide the yarn centrally over the center of the axis of the spindle. The thread guide consists of wire eyelet and thread board or support arm. The thread guide eyelet is mounted adjustably in the thread board to enable it to be centered. The latter is itself fitted on the continuous thread guide rail or lappet rail. The rail can be raised and lowered together with the thread guides while building takes place or winding takes place. It performs the same movement as the ring rail but with smaller traverse height. That is a continuous raising and lowering during layering and continuous lift by small amounts as switching traverse. As shown in this diagram, this movement of thread guide ensures that difference in balloon height caused by changes in ring rail position do not become too high or too large. Otherwise, the excessive tension variation in the yarn would produce correspondingly negative effects on yarn breakage rate and yarn characteristics. This one is a diagram of centering the thread guide. Thread guides must be centered from time to time using a setting device which is mounted temporarily on the spindle. In this diagram, S is that centering device. Since the yarn path does not run through the middle of the guide but on its inner edge, the point of setting device must be directed towards the inner edge of the guide. This diagram shows another guiding device, that is balloon control ring or BCR. Spindles used today are relatively long. The spacing between the ring and thread guide is correspondingly long, thus giving a high balloon. This has two negative consequences. A high balloon is associated with a large balloon diameter, causing space problems. The large balloon dimensions lead to relatively high air drag on the yarn in the balloon. This in turn causes increased deformation of the balloon curve out of the plane intersecting the spindle axis. This deformation can lead to balloon instability. There is increased danger of balloon collapse. In order to avoid these consequences, balloon control rings are used, each dividing its balloon into two smaller sub-balloons. In spite of its large overall height, the double balloon created in this way is thoroughly stable even at relatively low yarn tension. As in the case of lappets, The balloon control ring also participate in the lift movements of the ring rail but with shorter stroke length. Next, yarn guiding device is separators. As we know, most end down rises in the spinning triangle. If a break occurs in the triangle, then the newly created free yarn end must be drawn onto the bobbin and wound onto it. During this process, the broken end thread lashes around the spindle. In the absence of protecting devices, that is separators, this broken end would be hurled into the neighboring yarn balloon and would cause an end down on that spindle also. This procedure would be repeated continuously. The ends down would travel along the row of the spindles. In order to prevent this happening, separator plates of aluminium or plastic material are arranged between the individual spindles. In this diagram, these are those plastic or aluminium spindle plates or separators. These are all about yarn guiding devices on ring frame. Thank you.